Hi guys, welcome to Objects Following the Mouse exercise. In this exercise I just want to create three little objects that, pardon me, three little shapes that follow the mouse. So you can see the three shapes of these coloured dots. They could be anything, they could be images, they could be squares, they could be whatever. But at the moment they're just little coloured circles, and they're going to follow the mouse, and they're all sort of a certain distance away from the mouse. So you can see you can drag them along like that, or you can push through them and they sort of repel away from the mouse and then follow them again. So that's what we're creating. It is a direct sort of adaptation, only in that we do it a few more times, of this follow one exercise that's on P5.js, based on code by Keith Peters. But as you know, if you're going to use this code in your project, you need to understand each line and what it does. So I'm going to try and explain it to you guys now. So you can see, I'm just going to run through the code that we've got here in brackets. I'm just going to run through, we're going to deal with the first follower, which is 75 pixels behind the mouse, and follower one is the red one. So we're just going to deal with that red one there. I won't go into the other two because they're exactly the same, with a slight distance in how far they are behind the mouse. So the first thing that we do is that we have to find an x and y position that represents where the mouse is in relation to the previous x and y of the follower. So it represents where the mouse is in relation to the origin of the canvas. I'm just going to whiz through this, and then I'm going to take you over to a sketch file and we're going to talk through it with some diagrams so you'll understand it more. We then use those values to get an angle, and with that angle we then figure out the new x and y values, and then we use those new x and y values in the ellipse, and this happens every time we draw. Okay, so I'm just going to skip over now to our sketch file. So the first thing we're going to do is figure out what these dx1 and dy1 values are. So the reason we need these is because we need to get an angle. We need to get this is the old position and this is the current mouse position. We need to find this angle here. Yeah. Let me just draw, insert, pencil. We need to find that angle there. Yeah. And we're going to use that angle to find out where our new position should be. Yeah. So what we need to do is we use an atan2 function, and in P5 that will give us an angle based, it only takes one point and it gives you the angle of that point away from the origin of the canvas. So you can see, to get this angle we just need to figure out what this point here, the new point, the new mouse position, is in relation to the origin of the canvas. So essentially what we've done here is we've copied over this line and this position. We've just copied it over and dumped it there so that we can find our dx1, dy1 positions. Yeah, and then we can figure out what this angle is. So that's what we're doing. So the first thing we're doing here is dx1 is the mouse x minus the old x1 position. Yeah, and then the dy1 is the same but with the y values. So in this example where the old position was 250 and the new position is 100 and 150, that comes up as minus 100, 100. So this is minus 100, 100. It's good to work with some values just so you can understand what's happening. So you can see that that's minus 100x. So there's 0x. That's minus 100, and it's 100 down from in the y column, roughly. Yeah. So you can see that we're going to be given this angle. So here's that value. Angle 1 is atan2 of that point. yeah, that point there. And it's 135 degrees. It comes out in radians, so it's 2.356 roughly. So we now know what angle 1 is. Yeah, it's 2.356 or 135 degrees. Don't know where the degree button is. Anyway, degree rad. Okay, so that's our angle there. That's this angle here. That's what we want. Yeah, and what we're going to do is we're going to use that angle in order to calculate this new position. So this is the old position on the previous draw of the follower, which is red. Yeah, and this is the new position of the follower that we want to find, because since the previous position, the mouse was roughly here in the previous draw function, and then since then it has moved, and it's moved down here. So we need to find a new position for this follower. And the way that we do that is we use that angle, angle 1, which is the same as this angle down here. Yeah, that's angle 1. So we're going to use that angle to figure out what this distance is and what this distance is, so that we can then minus those two distances from the mouse position, which we know, to get the position of this, the new position of this follower. And the equation to do that is the mouse position. Well, let's just first figure out this here. So if you just look up a bit of your trigonometry, you will see that that length there, if this is the distance behind, yeah, we know that that is the distance behind, which is 70. We want it to be 75 pixels away from the mouse. So if we use cosine and our angle here times by the distance behind, we will get this length. And if we use sine, angle 1 times by the distance behind, we will get that length. Okay, so that's what we've done here. That will be done before we minus it from the mouse X position, and then all we're doing is minusing this distance from the mouse position. Okay, so sorry, this distance from the X position. So you can see that what we've got here is the mouse X is 100, cosine of angle 1 is negative 0.707, and the distance behind is 100 for this. Yeah, so times by 100. So the position we've got is approximately 170. The same with the Y position, except we're going to use sine. Okay, so it's 150 minus sine of angle 1 times by the distance behind, and that equals approximately 143. So you can see that this is our new position here. That's our values there, 170 by 143. Okay, now, so that's what we're doing on every draw function, and I guess what happens is that this mouse position, all we've done is move it directly in one line down, so that's why this angle is the same. Yeah, if you have moved up here, you will get an angle from the mouse from the old position that is slightly different, so you will then draw the follower coming in at a different angle. So that angle will change, okay? And then when you push back on it, it's the same thing. The angle will stay the same. So the angle will stay the same, but it'll just push this up out of the way if your mouse moves like this. And you can see that that is what's happening. Somewhere here. Okay, so there we go. That is all you need to know about how that works. That's follower 1. We've just repeated it 3 times, just changing that distance behind. Okay, so you can see there's a red one, a green one, and a blue one. And then there's our mouse, our one our mouse position. So we just use mouse X and mouse Y for that one, and that's the white one going around. Okay, so that's slightly complex. Yeah, I mean, I didn't write it, so I don't think I would have been able to write it straight from scratch, but what I can do is understand how it works so I can adapt it to my own needs, and I think that's probably a useful thing for you guys to get the hang of. So if you can understand this, then you can use it. I think that's your rule. Alright, let me know how you go. Any questions in the tech support channel.